Hi everyone, in this video we will discuss about capacitor. So how it will behave as initially, how it will behave as a capacitor. So consider a one capacitor C connected to current source through this switch. So to this switch. So how the switch is behaves is here for capacitor, and how the capacitor will act, mainly important capacitor, how initially will act, how capacitor will act for final condition. So these are the important. Capacitor is always initial and final conditions quite opposite to the inductor, quite opposite to inductor. Inductor is open condition, means capacitor will be short circuit condition. Capacitor is short circuit, means inductor will be in open condition, open circuit. So first we will see the conditions how we are taking. The switch is closed at t is equal to 0. The switch is closed at t is equal to 0. Hence, so what we are considering, t is equal to 0 minus corresponds to the instant when the switch is just open. T is equal to 0 minus represents switch is open condition, and t is equal to 0 plus means switch is just closed condition, just closed condition. So these conditions we have to analyze, we have to consider. So t is equal to 0 minus represents switch is open, t is equal to 0 plus represents switch is closed. The expression for the voltage across the capacitor is given by V is equal to 1 by C integral minus infinity to T I dt, 1 by C integral minus infinity to T I dt. This is the voltage equation for the capacitor. So now we will move to the initial and final condition, how we are solving. So just so minus infinity to t. So we are splitting intervals into two. One is minus infinity to 0 minus to t. So we are splitting that intervals into two intervals for easy analysis. So V of t is equal to 1 by c integral minus infinity to 0 minus I dt plus 1 by c integral 0 minus to t I dt. So here we are splitted intervals into two. So 0 minus minus to 0 minus voltage across the capacitor is V of 0 minus. So this is the V of 0 minus. So V of t is equal to V of 0 minus and plus 1 by c integral 0 minus to t I dt. So substitute in place of t 0 plus, substitute in place of t 0 plus. If you substitute, V of 0 plus equal to V of 0 minus plus 1 by c integral 0 minus to 0 plus I dt. So this, so 0 plus we have substituted in place of t, 0 minus to 0 plus, almost the switch is in just open and just closed condition, it acts. So this voltage across the capacitor is equal to 0. That's what finally V of 0 plus equal to V of 0 minus. So this is a very important relation for solving problems based on transient analysis. Very important. Whenever circuit we got, suppose if they ask you to find out the voltages across the capacitor, V of 0 plus equal to V of 0 minus equal to 0. So initially those values will be 0, since capacitor acts as short circuit. In short circuit condition, current will be maximum, voltage is 0. So current will be maximum and voltage is 0. So similarly in inductor, so current I of 0 plus equal to I of 0 minus is equal to 0. So those conditions are very important. But remember, okay. Next we will move to the next graphical representation. So, in graphical representation, capacitor we are taking. So, capacitor at t of t is equal to 0 plus, you can observe capacitor acts as a short circuit. At t is equal to infinity, capacitor acts as a open circuit. So, it is quite opposite to the inductor. Okay. So, these are the things we have to remember. So, here I will write some of the formulas for better understanding purpose: resistor, inductor, capacitor, voltage equation, current equation. So, in voltage V is equal to, in resistor V is equal to IR, in I is equal to V by R. These formulas are important. When inductor, in inductor V is equal to di by dt, and current I is equal to 1 by L into di by dt, 1 by L into integral I dt, and capacitor V is equal to 1 by C integral I dt, current I is equal to C into dV by dt. So, these formulas are important for your solving, for your problems. So, while we are solving these problems, so we will use these all formulas. Already once we have discussed it in class also. Just recall these formulas. These formulas are will use in the problems. Okay. So, this is about capacitor, and we will move to the next element called resistor. Resistor is same for every situation. So, it will not changes. So, changes are no in this resistor, because resistor is a energy dissipated element, power dissipated element. Capacitor and inductor are power stored element. So, this resistor will not change position for any time. So, if the cause effect of relation for an ideal resistor is given by V is equal to IR according to Ohm's law, or V is equal to RI also can take. From this equation we can find that the current through a resistor will change instantaneously if the voltage changes instantaneously. Current changes instantaneously, voltage will change. Similarly, voltage will change instantaneously if the current changes instantaneously. So, current changes, voltage will change, voltage changes, current also will change. So, this is the relation of resistor. So, resistor is a heat dissipating element. So, it will not store any energy. So, it will for every instant that resistor will not changes. Resistor will not change anything, right? So, resistor will not change anything means the position of the resistor is same for any condition. So, always for initial condition, for final condition, we have to take same relation for resistor. Okay, right? And here we will discuss about all the elements resistor, inductor, capacitor at t is equal to 0, at t is equal to infinite. So, at t, resistor is same for both the conditions, same. So, resistor is same. For inductor at t is equal to 0, it acts as a open circuit, and t is equal to infinite, one minute, I will erase all those things and I will write once again. I will take thin pen. So, R, L, C. So, t is equal to 0 condition and t is equal to infinite condition. T is equal to 0, t is equal to infinite. So, the resistor is same, resistor is not changes anything. So, inductor at t is equal to 0, it acts as a open circuit. So, t is equal to infinite, it acts as a short circuit. So, this is for inductor, and for capacitor it is opposite. So, t is equal to 0, capacitor acts as a short circuit, and inductor acts as a capacitor acts as a open circuit for t is equal to infinite. So, these conditions are important for solving the problems. So, resistor will be same for both the conditions, initial condition, final condition, but inductor is different and capacitor is different. So, if you remember any one element position, so automatically opposite to the other element, other capacitor element, if you remember, you can write inductor opposite you have to take, right. So, these are the things about inductor, capacitor and resistor. So, all three elements transient conditions. Transient conditions means t is equal to 0, t is equal to infinite, again t is equal to two conditions, t is equal to 0 minus and t is equal to 0 plus. T is equal to 0 minus represents just to open the switch, t is equal to 0 plus represents just to close the switch, t is equal to infinite means steady state condition, that is called switch is closed for longer time. So, according to problem given, according to situation, according to position of the switch, we have to consider this open circuit, short circuit or open circuit, then only you can get the answers. So, for solving the problems, you have to strong in writing the KVL equations for the networks. So, if you know KVL equations, if you know these initial conditions, these problems related to transient analysis are very easy, no need to worry about anything. Okay. So, this is about transient analysis for RLC elements. Now, we will discuss about problems in next video. Okay. Thank you everyone.